This video is about the rigid motion of translation. So the goal is to use coordinate vector and subscript notation to translate an image. So a rigid motion is the act of taking an object and moving it to another location without altering its size and shape. There's four types of rigid motion. There's a translation, a reflection, a rotation, and a glide reflection. A translation means dragging an object in a specific direction and by a specific amount. So there's three ways to notate a translation. There's the coordinate notation, which you have in the first set of parentheses, x comma y, an arrow pointing to the right, and then we have x plus or minus h and y plus or minus k. H and k are going to represent how much we're moving left, right, up, or down. In vector notation, we don't use any of the variables. We just use our h value and our k value inside brackets that look like little arrows. And in the translation notation, which is also known as our subscript notation, we have T to stand for translation. And then in the subscript, we write our h and k movement. So as a review real fast, h is going to move our x coordinate. So we're either going to move left if it is negative, and we are going to move right if it is positive. K deals with our y coordinate. So if it is negative, we're going to move down, and we're going to move up if it's positive. So let's try writing some notation. Describe the translation using all three notations. So in the first one, we have x, every point is moved up 2 units and right 6 units. So remember that right is going to go with the x, and up is going to go with the y. So we have x comma y, arrow, and then I need my new change. So x, in this case, we're moving right 6, so x plus 6, y up 2 plus 2. In vector notation, we're going to have our brackets with a comma. We're only going to worry about the changes. So right 6 is a positive 6, up 2 is a positive 2. We don't need plus signs if they are positive numbers. For subscript notation, we're going to have a T, and then 6 and 2 are written as subscripts. Number 2, every point is moved left 12 units and up 1 unit. So left, remember, deals with our x coordinates, up deals with our y coordinates. So I'd have x comma y, and we're changing x to the minus 12 because we're going to the left, so we're subtracting, and y plus 1. In vector notation, we just deal with the numbers again, so negative 12 for the left, 1 for the going up 1. And in translation, we're just going to take those numbers and write them as subscripts, so negative 12, comma 1. Number 3, every point moves right 8 and down 4. So right 8 is our x coordinate, down 4 is our y coordinate. So my coordinate notation would be x comma y changes to x plus 8 because we're going to the right, y minus 4 because we're going down. My vector notation, I'm going to take those numbers, 8 comma negative 4, inside the vector brackets, and my subscript, t with a subscript of 8, negative 4. Number 4, every point moves up 14 units. So the only type of change we have in this case is a y movement. Our x does not have a movement. So in the coordinate notation, when we have x comma y, we're just going to leave x the same, which means we're not changing at all. Y plus 14. When we use the other two notations, since there's no variables in them, we need to put a 0. So in coordinate notation, when x is not moving, we have 0 comma 14. And then in subscript, we have a t, again 0 comma 14. So now let's use the translations to move our graphs. So remember that every point is moved during a translation. The original point is named with a capital letter, and the new point is called the image. which is named with a capital letter with an apostrophe. So for example, our original would be A, which means that our image then would be A apostrophe. This is also called prime. So draw the image after the translation, label the graph appropriately, and then write the coordinates of the new points in the space below. So number one, this is coordinate notation, which has x plus 6 and y minus 2. That means we're going to move every point right 6 and down 2. So from each point, I'm going to count over 6 and down 2. When I label my new point, the same letter with the apostrophe. T moves right 6 down 2. S moves right 6 down 2. H moves right 6 down 2. And then I'm going to connect my sides to form my shape. Remember that the shape should look the same. We just moved it from a new place on our coordinate plane. So W is going to have the coordinates of negative 2, 5. T is going to have the coordinate of 3, 5. H is going to have the coordinate of negative 4, negative 1. And S is going to be at 5, negative 1. Number 2, this is vector notation, but we're doing the same thing still. So 2 means that we're going to move right 2, and 6 means that we are going to move up 6. So from each point, I'm going to count right 2 and up 6, and label it with an apostrophe at each new point. So right 2, up 6, each point. So in this case, there's 6 points that we need to move. And then I'm going to connect the sides to form my same shape again. And then I can identify my points. So D prime is now at negative 5, positive 7. E is at negative 2, 7. V is at negative 2, 4. I is at 1, 4. L is at 1, 1. And S is at negative 5, 1. Pause the video and complete the third problem in this section. So after completing number 3, you should realize that it's negative 5, 0, so the shape moves 5 to the left, but there's no up or down movement, and then gotten your new point. So G prime is 2, negative 2, E prime is 1, negative 7, O prime is negative 5, negative 7, M prime is negative 4, negative 1. So now let's work in the other direction where you're given a picture and you need to write the translation using all 3 notations. So when I'm looking for a translation, remember I'm always moving from the capital letter to the capital letter with an apostrophe. Always go to the same letter. So I'm going to pick, let's go from A to A. So I moved to the right and I went down. I need to know how many of each thing. So I'm going to count each grid line as 1. So I went right 1, 2, 3, 4, 5. And then I went down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I can write my 3 notations. So in translation, this would be, or in coordinate, this would be x, y to x plus 5 because we moved right, and y minus 10 to go down. In vector notation, we would have 5, negative 10. And in subscript notation, we would have t 5, negative 10. Same thing for number 5. Be careful because up in the right is where our original is, and our new shape then is down on the left. So I went to the left and down to get to my new shape. You can use any letter you want as long as you're tracing to the same letter. So for V, I went left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I went down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can write my 3 notation. So coordinate notation is x comma y to the x minus 10 and y minus 10. Both of them are minus 10 because we went left and down. Vector notation, I would have my arrow vectors 10, negative 10, negative 10. And for translating t with a negative 10, comma, negative 10. Number 10, find the coordinate of the image of each point and determine which quadrant the points lie in. So as a quick review about quadrants, remember that we have 4 quadrants on the coordinate plane. They're numbered counterclockwise. In the first quadrant, both points are positive. In the second quadrant, our x is negative, but our y is positive. In the third, they are both negative. And in the fourth, the x is positive, but the y is negative. So we're going to use the rule changing from x to y, x minus 4, y plus 3. So on each coordinate, our x coordinate, we're going to subtract 4, and our y coordinate, we're going to add 3, and then figure out the new quadrant it lies in. So for J21, 2 minus 4 is negative 2. 1 plus 3 is 4. So this would be in the second quadrant. Oh, negative 5, negative 7. So negative 5 minus 4 is negative 9. Negative 7 plus 3 is 4. Negative 4. So this is in the third quadrant. K, 5, negative 1. So 5 minus 4 is 1. Negative 1 plus 3 is 2. So this is in my first quadrant. E, 11 minus 4 is 7. And negative 7 plus 3 is negative 4. So this is my fourth quadrant. 3 more problems to look at. So K prime is the image. So remember that K prime is the image of the point K 3 comma negative 1 under the translation T. So K is my original point. What is the image of negative 2, 4 under the same translation? So first, we need to make a translation rule by looking at the 2 points we are given. So how does x to y change? So I'm going to look at, here's my x coordinate, my x coordinate. How did I get from 3 to 8? Well, I added 5. So we're going to have x plus 5. We move to the right 5. And then I have my y coordinate, negative 1 to 5. So how do I do negative 1 to 5? Well, I added 6, so y plus 6. Now I'm going to use this rule to get my new point. So I'm going to do negative 2 plus 5, which is 3, and 4 plus 6, which is 10. Same idea number 12. So again, I have my image and my original. So I need to make a translation rule. So I'm going to use my coordinate notation. You can use any notation you want. It's just your scratch work here. So how did my x change from negative 4 to negative 6? I subtracted 2, so x minus 2. How does my y change from negative 3 to negative 2? That's plus 5. Make sure that you're always going from the capital letter to the capital letter with an apostrophe. Now that I have my rule, 9 minus 2 gets me 7. 1 plus 5 gets me 6. So my new point would be 7, 6. Number 13, a figure is translated negative 3, 7. What translation moves it back to the original position? So to think about it this way, we moved left 3 and up 7. So I want to get back to my original spot, which means I want to do the opposite. So the translation that would move it back then would be right 3 and down 7. It's the opposite movement that is in the original.